we'll have more coverage on files. I mean, how to deal with different files when we start pandas. And today we realize that would be enough for us. That helps us to get a quick idea about files, like how to open files, how to work with files, all that gives us a quick and useful idea. Okay, now, so today what we do is we get it into another topic, what we call modules. So let's finish modules today. Mostly we'll try to finish because it's not that big topic. But the only thing is uh, this coverage is important for us. So we are trying to have that coverage. So after this, I think we covered files and then modules. Maybe there is one more topic, uh, this one, regular expressions. After that, we might jump to OOP. Then I will discuss exception handling once after completing OOP, because OOP object exceptions are nothing but classes. To get that quick understanding, maybe we'll discuss that once after we complete OOP topics. So now, module. What is a module? This is not something new for us because we already know what is a module, and we are working with modules. It's not we don't know about modules. We are already using modules. That only thing is we should have that idea. What is a module? How to work with modules? That's all. How to import modules? Types of modules. I mean types of imports, and then packages. Difference between modules and packages. All this. But this is a very simple topic. This is not really something complex. So module means simple. As discussed, as just we discussed, it's a collection of variables, functions, classes, everything. Simply speaking, suppose I open this Python file, .py file. This is a module. I open this one. This is a module, right? This .py is a module. Even this .py is a module. All these are modules. Any .py in Python is a module. So what is there inside this Python file? That simple Python file is a module. The question is, what is there inside this Python file? It is collection of variables, collection of methods, collection of classes. Of course, we didn't yet discuss, but it is a quick idea. All this together, we call it as modules. The purpose of modules is we can avoid duplicate of variables, or if you want duplicate variable names or method names or class names. So module is the best approach. So this allows us to modularize code. Okay, so that is what module. Simply speaking, it is just a simple Python file which has variables, functions, and classes inside that. The program itself in Python is a module. Okay, and file name which is having any file name with .py is nothing but module. Simply speaking. Okay, and the advantage of module is modules are reusable, and they provide readability, right? When you have that concept of modules, so we can also increase readability. And third thing, this is very important, modules avoids naming collisions. What is that naming collision? Suppose I want same method to be defined for multiple times, and we cannot do that in the same file, same Python program. So when you have multiple modules for the same method, then it helps us to accomplish that requirement. So means what? We can avoid naming collisions with modules. It's something like packages in Java, something like libraries in C language or C++, like packages in C#. So that is the simple idea. But the difference is here module is nothing but just a simple Python file. That is the idea. Package means collection of modules. Already we are already using packages since the beginning. You can see all these are packages. You can see all these are Python packages. What is there inside package? You have all collection of modules, means collection of Python programs, collection of .py files, and that is called a package. Okay, so that is what we need to understand. So that's all, friends. Now after that, how do you define a module? This is a quick idea about module. We don't need much more this thing in that. So this is a an idea what module is, why we need modules, all that. So all these functions, modules, packages, classes, all this promote code modularization. The advantage of all this is we can break down code into blocks by using this kind of concepts like functions, modules, packages, all this, or even classes. All this promotes code modularization. Okay, that is fine. Now let us take an example. How to create a simple module. See, let us just take a simple example to talk about modules. Suppose you see here, I just create one Python program. Just a minute. So what happened to this? Array. So now this mouse is stuck here. Just a minute, friends. Simple. We can take any other example as well. Something already there. We can take. We do one thing. Otherwise, I'm doing one thing. Let me directly create it. Possible. What happened to this mouse? Otherwise, I'll do one thing. I have already some. Excuse me, friends. Yeah, let me use these examples because there is some issue with the laptop, but that's fine. So I have already prepared this module topic. See here, this is a very simple one so that we can continue without break here. Okay. So now if you see this, so these are all modules we created. So and I created a package module here and I kept all my .py files. And we know what is a module. We are already working for since the beginning of our Python classes. This is not new for us. Suppose we create a module here, if you see here, a.py. So let me open this, friends. Okay, if you see here, a.py, this is a very simple module. And I just added a print statement in that. Now I created one more module, c.py, b.py. Let me just open all this so that you get that quick idea. And then So test.py, few more examples. Okay. And then test2.py and then test3.py, few examples just to understand the concept of modules here. Okay. So now let us just quickly start with this simple example of this one. What is this here? This is a module we created a.py and just added a simple print statement. Now in b.py, if you see here, I am doing what? An import here. So import a, and then I try to use that simply I'm trying to print, do a print here. That is fine. When I say import a, even whatever that is there inside this a.py, this print also gets called when I run this b.py. Suppose if you see, right, we have two variables here. We have one print here from this file b.py and one print from a.py. Suppose if I run this file, let me run this now. So what I do, so right click, or otherwise you can run from here one. You can just choose what is that file name here. That file name is not all this. This is what is it? b.py, right? Current file. Yeah, run. You can see we got A and B in the output. So if you look at it, A is coming from this a.py and B is coming from b.py. And both are coming from the same file b.py. How this is coming? We are importing A here. Suppose if you don't import A, see this. I'm commenting this. Now run this. Now you just you can see here only B. And we are not seeing output from which module? From this module a.py. You know why? Because we are not importing a.py in b.py. So that is why we are not seeing the output. Point is simple. Here when we have modules like this, if you want to call members of one module, okay, in another module, we should import them. What is that we should do? We should import a module in another module. So this is very important. And for that we have, so this is something which we should know in module. That's all. If you understand this, module topic is over. Hardly within half an hour, we can just quickly understand how to reuse modules. If you know that, we are done with modules. And here and there are some miscellaneous things we need to quickly get some idea. That's all, friends. So now let's just quickly get into that now. If you look at this here, so we have imports about, so this is a simple program. Maybe even if you want, you can try this example as well. Suppose you copy this data. Okay, I have just a variable and two functions. Now go to the Python program. Maybe here instead of that, I want to put this here. Now I have a module a.py. I want to reuse these functions and this variable in b.py. If I should do that, if I want to reuse the members of a.py module in b.py, then I should import that module. You can see import that module name. Then what can I do? Here I can print whatever that is in a.py. In a.py, we have one variable and two functions. Once I import that A here, that module A, then I can start using that. Suppose I can just directly print A here, and similarly, and of course, I should do one thing. So I should call this as A.A. I'll talk about all this one by one. So I imported module A. Inside this, there is a variable. Then while calling it, how should I call members of this module A? This is a module. Whatever we are seeing at the top is a module A, this one. From that, if I should call modules, I mean any member, then I should say that module name dot that member name. You can see here. Okay. So similarly, I want to call function from module A. Then how do I call A dot F1? Again, I want to call another function from module A dot F2. Now I can run this. Now you can see some output here. See here. What is that? So first thing it is printing B and printing A. Of course, I can do one thing. That I can make a small change here. So I can remove this and now I can print this. This is from current module B. This whatever B we are printing. Now run this, you get line by line output. That makes more sense to us. Now you can see we are printing B from B module and 10 from A module and ABC from A module, BBC from A module. And this is simple. This is how we should call members of one module in another module just by importing. And this is the concept of modules. Just quickly summarizing, module is nothing but a simple Python program with .py extension. And we can reuse modules by doing imports either within the same package or in other packages. Okay, if it is within the same package, we directly call module saying import or from import. If it is package to package, we have to do importing of packages. That we'll see it yeah, little later in today's session itself. So now finally, let's see how to import modules, types of module imports, and then we'll talk about packages and types of package imports. If you understand this, this is enough to work in any development. So now, if you look at these are the two types of imports we have. So what is that? Normal import and from import. What is normal import? Simply speaking, whatever we just discussed with example now, this one, import module name, right? Or just importing, this is for importing one module. This is normal import. Second one is importing multiple modules. If you see this example here, sorry friends, we have we are importing multiple modules separated with comma here. You can see here. Okay, we can import any number of modules like this. But of course, using an alias name, something like as M1, okay, and similarly as M2, okay. So aliasing is always a standard thing we follow in development as M3, something like this. And that as is nothing but it's a keyword which is used to provide alias for a module name. And this is something we regularly apply in development. This aliasing is something really important while working with modules. Okay, so this is the idea. This is how we do normal imports. To import just one module, we apply we just say import that module name. To import multiple modules, we use import module 1, comma module 2, comma module 3. Of course, aliasing is not mandatory, but it is a standard practice we follow in development. Even here also, we don't use alias for module name. So generally, we can say as M here, that is aliasing. And while calling this module, generally how to call members of module, this is how we call that module name dot, you can see here. Module name dot, if you see, this is module name dot that member name. And syntax wise, if you see here, this is the syntax. What is that? Module name dot member name. That's all. If you understand these things, we are done with module, simply speaking. Right? Suppose you get into the example here. Let's see the example. We are importing module, right? This is the module, see, which is that a.py. In this, we have one variable, two functions. And what is that we are doing? We are trying to import that. So in this module b.py, as this is a name of this module is so small and short, you don't need alias for this. When we need alias for a module, when the name of the module is little lengthy. If it is too short, you don't need alias. right? Even this is not just, it's just one character length, this module length is. So we don't need any aliasing for this. Still, if you want, you can try that. Suppose instead of A, I just say some M1. Then I can do what? I can call members of this module A saying that M1 dot A. Similarly, okay, let me just a minute. Yeah, you can see now M1 dot F1, M1 dot F2. This is how we provide aliasing. Okay, and then just run this now. Now you can see we got this. We don't have any change in output. Only thing is an idea how we can provide aliasing. Just to test that, we have given alias for this module, and then we just call members of that module using alias name. And even out there, we don't have any change in output, but the approach of calling members changed here. That's all, friends. So this is one thing. This is how we import module. Suppose there is c.py. Okay, you can see c.py. So I want to call, so remove these things, friends. Do one thing. We don't need all this. Suppose I have something like name equal to some, okay, John, and then after that, some age equal to some 20 or some 30. And we are using few methods like, def print name, okay, colon, okay, just print that name, print if you can start codes, okay, and end codes, and then you can simply say name is okay, just pass name, just for testing purpose. That's all, friends, nothing more than that. So def print age. I'm just taking one more method here and just saying copying this and copy and paste here and just print age here. So let it be like that. So this is the module c.py, and these are the members. You can add still, if you want to add few more members, you can add that to this module. Because in development, we have very big modules and we keep importing them into other modules. So this is just for quick idea. Now I want to import members of this module c.py. So I write into b.py. I am showing you how to import multiple modules. Already we are importing a.py and we tested that in b.py. Now I want to import even c.py into b.py. Simply what is that I should say? Import a as m1, c as m2, or a as a1, otherwise something like that. Whichever you think is best alias name that you have to pass it. Here I'm just showing you how to provide aliases, how to do normal imports. This is a normal import, friends. Whatever we are doing is this one is a normal import, right? I imported C as well. Now I want to use members of C. Okay, these are members. These are members which we are calling from A. So I can just add a print here. Okay, module testing from module A. Similarly, what is that I can do? This is only just for here. I just for testing purpose, I am showing you all this. But in real time, we don't do all this. We just directly import modules and just do and import them, call those members wherever we want. That's all, friends. We don't print like this is from module A or module B when you do development. Okay, now what is that I want to do? I want to call members from print. If you want, you can members from C module, module C. If you want, you can call them directly, or else you can just simply call the method names. What is that? M2 dot. You can see here print name that gives you name. Similarly, print M2 dot printage. That's all. Now you run this now. This time you can see in this program, in this module b.py, we are importing two modules. One is A, other one is C. We are importing these two modules. And again, if you want to import one more module, put comma and then import that. If you want, you provide alias, else you can directly provide module name. If you are using module name directly, then here while calling members from that module, use that module name. Okay, here we are using aliasing, you see here. If you are using module name directly, then it should be module name here, not alias. In case if you are not using alias. Got it, right? So that is the idea, friends. So remove this. What we do? Remove this one and then run the program. Now you can see here. And just make a small change here from C, module C. Now run this. Okay. Now you can see this output from module. Okay. Why? Because this we should not, this none is coming because these methods are directly printing that name and age. So, and we are not returning anything. So already we had discussed methods, right? In such cases, passing this method calls to print statements is not a good idea. Okay, so that's why we are getting none. So now run this now. See here. Also, there is one topic I need to discuss in functions, friends. Global and local variables. I think that is something which uh, you know we didn't cover actually while discussing functions topic. Other all things have been done. Maybe again after modules, I'll just recap that global variables, local variables. Also, of course, while discussing classes, also there are different types of variables. Even there, we can cover that topic. Instance variables, static variables. While covering that, even we can discuss about local and global variables as well. Should be fine. But just an FYI, we need to cover that as well so that the whole sum of functions will be done. Got it, right? This is the idea about importing modules, and this is a regular import. Another famous import is from import, and these are useful for interviews as well. Sometimes people may ask in interviews, even in certification exams. But this is overall idea. If you know this is enough. How to import a module? What is a module? Right? How to import simple one module, multiple modules? What is aliasing? If you understand these things, this is much more enough for us. Okay, next after that is okay, we can close this for a while because if we are already doing the same here in these files. Now after that is the next thing is we did discuss about regular imports, it is done. Then from import. So difference between regular import and from import is regular import can be used to import multiple modules, and from import is used to import one module. We import it. This is used to import multiple members from the same module. It's like working on one module and different members. Got it, right? This is also popular kind of import in development. But the difference is, what is the difference between from import and regular imports is, if you want to import more than one module at a time in a code, then we can apply these regular imports or normal imports, whatever we had discussed so far. And from import is used to import one import at a time. But if you want to choose some specific members to import, this is like doing a direct import. Okay, if you want to choose some specific members to import from a module, then we use from import. This is all at most applied on one import, but regular imports are applied on multiple imports. But difference is which this is from import is most flexible. If you want to choose a specific member to import from a module, you can see here. I'll show that with the example that gives you a quick idea. And also we don't need to call that module name dot member name every time if you're using from import. Okay, this is something much more faster than regular imports, much more simpler than regular imports, much more easier than regular imports. That is from import. This is short and fast, but limitations are this is applied on at most one import. Regular imports are applied on multiple imports. Okay. And in one import, in one module, if you want to choose specific members, then prefer from import. If you want to import members from multiple modules, choose regular import. And you can ask me a question, which is most used in development? We use both, friends. If you look at that import at the beginning of the file in our programming, we prefer both. It's not like we only use normal import or we use from imports. It depends, right? There are times where we use regular imports as well as from imports. Let us see this example from import now. We are good with regular imports, right? How to do regular import, how to import, what is aliasing. Even aliasing is applied here also. See, we are talking about aliasing, right? Even for this from import, you can provide an alias for this members. These are members, not you can see here that member one, member two. Even for these members, we provide alias here. Got it right? So now the point is from import. We had already discussed about regular imports. Now what do we do? Add few more members here if you want something like some x equal to 100, some z equal to 1000, something like that. Just add few more members and also add few more methods. Okay, if you want, you can return them. Already we are good with methods, right? Define F3, print some. Okay, F3 here. Something you can add. If you want, you can add a class as well. Now you don't need to worry. Class some test. Just say pass. Don't write anything under class. Just add a class. This makes a much more sophisticated module. Okay. So now under B, let's import in B. This time we are implementing from import. How do we do? You can remove all these friends. So let's apply from import. Now from import, from what you can say, what is the syntax here? From module name. The syntax looks like this. If you want to know how to work with from import, from module name space import that members. You have to import whichever member you want from that module. Member one, comma, member two. Okay, comma, dot, dot, dot. Okay, comma, dot, dot, dot. Something like this. If you want, you can do one thing. We can provide aliasing for this member, something like as M1, as M2, something like this. Now this is the module we have a.py. Now these are all the members in that a.py. Okay, we have variables, methods, and classes, class. Now I want to import them all this in the b.py, not with regular imports, but with from import. Then what do I do? From A. Okay, I have so many inside this module. And I don't want to load all these members into my this thing, into this table, variable table at memory level. Then what I can do, I don't want to import all this. Got it right, friends? So if I say regular import, import A, then all members of this module are available to B. Then you say that A dot some X and A dot some Y, A dot some Z or something. Okay, fine. So symbol table, what we call technically. So all members of this module are loaded into the symbol table of b.py. Got it right? So at memory level, this is actually again language interpreter concept. We don't need much deeper in that. We are not at that level. We are not developing anything like that. So just an FYI. Suppose if you want to choose which members from this module available to your this module b.py, then from import is best approach. Then what I can do, of course, don't use regular import now. Use from import, from import. Suppose I just want import X and Y. That is enough for me. I don't need A again. Of course, I am removing A. Okay, leave this. And among all these methods, I don't need all these methods. I just need some F3. Suppose assume that I want to choose F3. That is enough for. And again, if I want test, I can choose that specific comma test. So these are enough for me, right? If I want to import some specific members from a module, you can see what is this module a.py. Then we can use from import. And here you can see from that module name, import members, whatever you want. If you want, you can provide aliasing even for members. You got it right. So cannot find reference in a.py. Okay. Y is not there. That's why it is saying that. No problem. We can add y. Y equal to some 500. No issues. Now this should work. Okay. Y now we added. This error is because earlier this y is not there in a.py. Now if you see, we have three variables, but we are choosing only two here. And we have how many methods? Three methods. We are just importing only that specific method F3. We have a class test and that we are importing here. And we are choosing that thing. And here, when you just use from import, again, you don't need to say like in regular imports, module name dot that member name. That is not needed. You can directly call them. Just simply say print X. See, this is much more simplified compared to the previous one. Okay. Now print X, print Y, and print Z. See, this is much more simplified. Okay, Z we cannot call because we are not importing. See, I can only call X and Y and then print F3 and then print. If you want to call test, okay, we can do one thing. We can directly do one thing. You create some object for test. See, and then print T. It just prints the object of that class. That's all. If you print T, we get address of that object. And this is how we apply from import. See here how simple this is. Now, in this approach, what is the advantage is here we are choosing some specific members. Only those members are available to your module. Remaining all are not loaded to your symbol table or your program table. Okay, now run this. See here. This is from import. You can see this is function. We are not calling function, right? See, if I am just printing function here, remove this. F3 is a function call, right? You can directly say F3. And now you run this. See this one. Now you can see 100, 500, F3, and this is test class object because we are just printing reference. We don't have anything inside test class. No method, no variable inside that. Just creating object and printing that so that we just get that address of object. So this is how we work with from imports. Interesting, right? This is difference. Now, if you just compare the previous one and this one, see, copy this, Control X. What I am doing is let me put that. Okay, I'll do one thing. Yeah, let it be this stage. This is regular approach. This is from import. Okay, let both be there. Now you can do a comparison. Okay, this is what we are doing with regular imports. So you can see you have to provide import that module name, and you have while calling members, you can see we have to say module name dot member name. This is all something we do with regular imports. With from import, and also another thing with this import is when you do regular imports, all members of that module are by default available to this module b.py. And it's up to you which one you want to call, but they are loaded to your module as well, to your program. This module program table b.py. So here means performance wise, when you are using regular imports, make sure you are importing all that necessary imports. Don't do unnecessary imports, because all members of this imports are available to this module b.py. Members of A, members of C, all this are available to b.py. Of course, it's up to you which one to choose, but they are loaded to your program table, b.py program table. This is something going to a buffet. Got it right? Which one? Regular imports. And there, all items are loaded into that room, buffet room. Of course, you choose which one you want to eat. But what is that hotel people do? They load every item there, right? People sometimes eat them, they don't eat them, all that happens. This is buffet concept. From import is going to a regular hotel where they just serve when you ask something. That is something more or less like going to a regular hotel. Simply just a quick comparison. Here, the wastage of food is very minimal compared to the buffet system. Why here you choose what you want and they serve what you want, and wastage is reduced. Simply speaking, just a quick comparison. That is the idea, friends. Right? You add idli, dosa, and then something like some other pizza or something or burger. They just give you only that. So the advantage is that wastage of food is reduced, friends. Okay. So that is the idea, friends. Got it now? So you can run both. You don't have issue. Module A has no attribute. So where is that? Maybe at what level we are getting?
Line number 5, I think.
Line number 5. Yeah, we removed that A, right? Yes. We'll do one thing. We comment this. Let's comment it because it's not there, right? Let me comment it. Okay. Let's run this now. Arre. Today I came to my native little working with what happened to this? This mouse is just a minute, friends. Somewhere mouse got stuck. But this is the idea. If you run this, that all that output we can see there. Arre. Okay, should be fine now. Now I got it. Yeah, let me run it now. So this was the idea, friends. Okay, let that mouse come. Meanwhile, we can just quickly talk about this. Yeah, somewhere there is a little glitch in this with this mouse today. Okay, now let's run this, and still we have Attribute error. A has no attribute A. Okay, I did. Let me comment this. We are done with this. Let's run this now. This should work now. So you can see the output there. So
Are you
even
sharing
from,
your screen?
yeah, I'm sharing my screen. Can you see my screen, friends? Or everyone has issue?
Sir, we are not seeing screen.
Oh, should be issue with the internet. Again, I'm resharing. I'm resharing my screen. Can you see it now? Can you
Yes,
confirm if
sir.
you can?
Yes, sir.
Yeah.
Yes, sir.
Okay. Okay. Yeah. Here, this is remote, right? Net sometimes not that great here, but it's okay. We'll manage. Just for one day, if we can manage, we'll be back to Hyderabad. So this is the output. See, we don't see big difference. Whatever we are importing here, that we come from import, and we whatever we are calling from with regular imports, that we get as output. So this is fine. But this is overall idea between how to work with both imports, which is how regular import is, how from import is, which is performance wise, which is best, and which one generally we use in development. We prefer both, but while using regular imports, you should be little more cautious because they try to load all members to your module. So that's why you have to be little cautious. That was sometimes even when we import unwanted modules, our seniors will tell us, like, our architect or someone at manager level. Okay, they just keep telling us just remove those unwanted modules because they unnecessarily add this thing to the performance. So these type of comments we hear from the senior level people. Okay, so that's why just giving you an idea. We use both, friends. If someone is asking a question, which one should I use? We use in combination of both. Okay, this is quick idea about types of imports. Okay, so we are done with that import thing. From import all this stuff, and next one is quickly talking about built-in modules. Okay, we have discussed about modules. Let's quickly talk about another important thing. What is that? So far we discussed about modules, right? About imports, types of imports, and aliases. Aliasing, that is also something important, even at least for some exams. Okay, certification exams. And then after that, next one after that is here, if you see, built-in modules. What is built-in module? Generally, when we talk about modules, we create our own modules, whatever you can see here, all these files, whatever we creating here, .py files are user-defined modules. And in programming, we also use what is that we call built-in modules. Let me just show you that as well. We'll quickly go through that once and then. So where is that? Okay, no problem. Even if it is not there, I can quickly go through that once. Maybe we can add that here at the end of this file. Somewhere I'll just add it here, friends. Maybe just. So built-in modules means something like which is already existing, and we use a lot of built-in modules in real development. All that APIs that are provided by the Python people, even our project level APIs will be there. We create Our developers will create that to create that project infra. Even there we use them. They also act as a semi built-in, which were developed by our internal team. Okay, so now here for quick examples, we have all this built-in modules, something like math, comma, OS, comma, sys, comma, all this. There are so many. If you ask me, there are so many built-in modules. First thing, one important tip I'll tell you while working in development, something very important to observe about built-in modules is if we develop those modules, we know what members are there, what variables, what methods, what functions, what classes, what enumerations are there in that. We know that. But built-ins, we don't know, right? Suppose you want to know what is there in that particular module or package. What is that? You want to know what members are present in that module or package. Then the best thing always is what, friends? See, do one thing, open that Python console. You want to know about some module, right? Or package. Otherwise, there will be sometimes it will be packages. Simple. If you ask me what is package means, you can see here without asking, without even discussing. All these are Python packages, collection of modules. Just open any one. See, you can see collection of modules is a Python package. Okay. So now, suppose you see here, I want to know about this, some dir of math. Okay. Of course, you do one thing, import math. Okay. And dir of math. Dir function helps us to get metadata of that particular what, friends? Of that particular this one, friends, either module or package. Now you can see here, if you look at this, it is giving all that magic variables, everything there, right? If you see, array. No problem. You can see these are all built-in methods. I think this got stuck. There is a little issue with mouse, friends. I'll get it set by tomorrow. You can see here a cos h. Otherwise, I do one thing. Just simply I can say import OS. Okay. Then dir of OS again. I am trying to get, if you, this is something really important because this is what we do generally while working with custom APIs, because we don't know what all methods are, variables are classes present in that package or module. What we do is we apply this dir and see what different members are there in that. Like this, you can see here there are so many, and choose which one to apply for that requirement, because we work on something, a framework which is completely exclusive to our company. And this dir of that is will rescue, it will come to our rescue, because if we should apply something, you should know, right? If it is from Google, we can go and Google it and get it. But if it is internal APIs, we cannot Google it, friends. In such cases, what is that we have to do? We have to rely on documentation. When we are relying on that, again, we need to know what methods or classes are there in that, because we need to apply for development, right? So generally we use this trick here. This is a simple trick for you. We apply that dir command and see what members are there inside that. Okay. Let me try to expand where this mouse is supporting. Okay. Just, but this gives you an idea, right? So this is one important hack for you, important useful tip for you. If you want to, if you don't know anything about some module and you want to see what is there inside that module, what variables, what methods, what classes are there, then apply this use this dir command. This is one quick info, friends. Okay, so that's the other important thing. After that, dir is completed. Tomorrow I think I'll just talk about packages for some time, and then also one more important is how to add that main to the program. You can see this is how dir works. See here, friends. So this is a simple dir. When you directly apply, it shows something. Okay, it is from some particular module there. Okay. Similarly, one more topic you need to do is there is another from import asterisk. So that also we need to discuss tomorrow. That with all this and this kind of thing, how to explicitly add this main to the modules. right? Generally, when you are trying to create a driver program, how to test that main method is present and how to call members from that module to create a drive, how to create more mature driver program in modules that we see in tomorrow's session. There is a slight issue with this mouse here today. So I'll try to fix it by tomorrow's session. So, but this is overall idea like about modules, types of modules, aliasing. Even here we provide alias for this. For X, can provide X1. For Y, just for idea sake, I am doing that. But for just for one, a variable with very simple names, we don't provide aliases. Y1. So, okay, here you can simply say that X1 and you can say Y1. Even we can provide aliases for members as well. See here, it works. We get the same output. And this is the concept of aliasing. Got it right, friends? So tomorrow what I do is I try to cover up on packages and then other important things which I just showed you now, adding that main to the program, all that stuff. We don't have many programs today. Just let me share you this with you just for testing purpose. These are all very simple and straightforward, friends. Let me just share this with you. Okay, this is b.py, whatever we are importing, and this is a.py. Okay, this is a.py, sorry. This is for testing purpose. You first create a.py, then c.py, and then b.py. You can create as you like, friends. Once you understand the concept, it's up to you, friends, how to play around that. Okay. It's not like we should choose something specific. Order, it's up to you, how you play with it. This is c.py. Hope all of you had a clear idea, friends. Okay. So I shared all three files. First one is c.py, second one a.py, third one b.py. Okay. So I'm stopping recording. Tomorrow we'll complete this